Okay, so today we want to take a look at the other part of 6.1. We want to take a look at some of our quotient properties. So remember, quotient is division. And so when we divide, just like when we multiplied our exponents, remember we added those exponents. Not a power raised to a power, but when we were actually multiplying like 4 to the 6 times 4 to the third, if you recall, we would have added those exponents. So it makes sense that if we are dividing, we would do the opposite of what we do when we multiply. So that's actually the rule. So we're actually going to subtract our exponents. And the reason why this works, if I've got 4 to the 6 divided by 4 to the third, remember, if you think about what that looks like in expanded form, this would be like 4 to the 6 is 4 times 4 times 4 times 4 times 4. That's 6 of them. And then it would be divided by 4 times 4 times 4. So if you think about this, 4 divided by 4 is 1, so that cancels out. 4 divided by 4 is 1. 4 divided by 4 is 1. So all of those cancel. And then you're left with just 3 of them, right? And so that's where we get our 4 to the third. And so that's why this works, okay? That's why the rule is the rule. So when we are dividing with our exponents, we're actually going to always subtract the top one minus the bottom one. Okay. Also, 2, if we've got the power of a quotient property, so if it's something like this where the entire thing is in the parentheses, that means that each individual piece is raised to the 5th power. So if it's 3 halves raised to the 5th power, you've got 3 raised to the 5th power and 2 raised to the 5th power. So you do both of those. Okay, and then the last thing we're going to look at today is this power of a quotient property. So this is with our negative exponent. So just like when we had our negative exponents and we had just the 1, we would move it, right? We would move, if it was in the top, we'd move it to the bottom. If it was in the bottom, we would move it up to the top. Well, the same kind of concept here. So you can think about it as the way that you're moving it is you are finding the reciprocal, you're going to flip it, and then just make that exponent positive. And the reason that works is because, remember, this would be the same as 2 raised to the negative 2 power divided by 5 raised to the negative 2 power. And that's because of this rule right up here, right? Every part gets raised to the power. Well, if we think about it, we know that we've got to move stuff around because we can't have our negative exponents. So that means the 5 to the negative 2 power has got to come to the top, and that becomes 5 squared. And then the 2 to the negative 2 power has to come down to the bottom, so that would be 2 to the 2nd power in our denominator. And so that's why that rule is that. So we can think of it as just finding the reciprocal and changing that exponent to a positive. Okay, so let's look at some actual problems that we can put this into practice. So if I've got 5 to the 6th divided by 5 to the 4th, remember, let's think of that as 5 times 5 times 5 times 5 times 5 times 5, 6 of them, divided by 5 times 5 times 5 times 5 times, just 4 of them. Sorry, whoops, just 4 of them. So that would cancel. 5 divided by 5 is 1. 5 divided by 5 is 1. 5 divided by 5 is 1. So I end up with 5 to the 2nd power. I've got 2 of them. So we end up with 5 to the 2nd power, which works out because 6 minus 4 is 2. Okay, now when I've got more than one variable, remember, your only like terms are the ones that are the same variable. So the x to the 6th, we don't do anything with that. That's going to remain x to the 6th. But then I've got 5 y's up here and 3 in the bottom. So if you think about it, I have 5 stretched out across the top, 3 across the bottom. So 3 sets would cancel out, and I would be left with 2 y's, and they would be left on the top. So I'd have y to the 2nd, which follows along with our rule of subtracting our exponents. 5 minus 3 is 2. Okay, now let's look at number 3. Got a couple things going on here. I've got the a squared b to the 4th. And then in my denominator, I have ab to the 3rd power. Well, remember that this means that every part of this is raised to the 3rd power. So a is raised to the 3rd power and b is raised to the 3rd power. So that's really important to remember. So now, if I think about this, if I were thinking about subtraction, this would be 2 minus 3. That's a 3 there. 2 minus 3 is negative 1, right? And I know I don't want negative exponents. And so this is one where I really like to, think of why the rule is the rule, right? If we think about this, this is a times a. And in our denominator, we would have 3 of them. So that would cancel and that would cancel. And the one that is left over in my denominator. And so I want it to stay in the denominator. That's the way we can avoid having that negative exponent. Now our b's are a little different. I've got 4 of them up top and 3 of them on the bottom. So that will cancel, that cancels, and so the leftover one is left over on the top. So we end up with b divided by a. So you want to kind of think of, where are your pairs and where are your leftovers? If I were to just simply follow the rule of subtraction, I would have 2 minus 3. I'd have a to the negative first power. I can't leave a negative exponent, and so I end up coming to do a little bit more work. Okay, let's look at this one. We've got 2/5 raised to the third power. So that's the equivalent of 2 to the third divided by 5 to the third. Now, you could technically, go ahead and 2 to the third is 8, 5 to the third is 125, and that's perfectly fine, but we're working with exponents right now, so I'm just going to leave it like this. Now, on the next one, I've got x to the third divided by y to the second, all raised to the 6th power. So remember, this is the same as x to the third raised to the 6th power divided by y squared raised to the 6th power. We have a power raised to a power. The rule for this, remember, is to multiply. This is x to the third times x to the third times x to the third times x to the third, 6 of them, right? So I have 6 groups of this. There's 3 in each group, so I end up with x to the 18th. Now for the y's, it's y squared, but I've got 6 sets of those. So I've got y squared, y squared, y squared, y squared, 6 of them. So 6 sets of y squared gives me a total of y to the 12th, which makes sense with our rule because we know we multiply there. And that's my final answer. Okay, now on number 6, if I'm looking at this one, be careful here. Everything gets raised to the second power, including the 3. So this is 3 raised to the second power, and m to the third raised to the second power. And also n squared raised to the second power. Don't forget that the 3 gets raised to the second power as well because it is in the parentheses. So 3 raised to the second power, we can go ahead and make that 9. M to the third to the second power. So I've got 2 sets of m to the third. So it's m to the third, m to the third. So I've got 6 total there. So m to the 6th. And then in my denominator, n squared raised to the second power is going to give me n to the 4th. Okay, let's look at one more of these. So I've got a to the third divided by b squared. So that's going to be a to the third, I've got a divided by b squared all raised to the third power. Sorry, I said that wrong earlier. So a to the third divided by b squared to the third. So a to the third would just remain a to the third. But here I've got b squared times b squared times b squared. So I have a total of 6 there. So that would be b to the 6th. Okay. We'll look at these 2 tomorrow. That'll give us something to look at tomorrow during our synchronous time. And let's just jump down here and we'll do a few of these. These are the ones with our negative exponents that we want to flip it, find the reciprocal, and then make that exponent positive. So if I flip 3/5, that becomes 5/3 raised to the third power. So that's equivalent to 5 to the third power divided by 3 to the third power. And then if I actually work that out, 5 to the third power, 5 times 5 times 5 gives me 125, and 3 times 3 times 3 gives me 27. Okay. Now looking at another one here, we've got a lot going on. So here, if I were to first flip this, would become z to the 7th divided by x, y, to the third. Okay. Now, on this one's a little bit different, okay? So when I look at this, I'm not sure, to the 7th, to the 5th power, x to the 1st to the 5th power, and then y to the 3rd to the 5th power. So this becomes z to the 35th power, x to the 5th power, and y to the, this was a 3, y to the 15th power. A lot going on there. We'll go through that one again tomorrow because I know there's a lot going on there. Okay? Okay. Now, let's jump down to these on the bottom. We'll do a few of those, and then I will let you go and we'll finish out the rest tomorrow. So I've got x divided by y, all raised to the negative fifth power. So I'm doing the same thing I'm doing up here, just up here we expanded it. So xy, first of all, needs to flip around. So this becomes y divided by x, and it's now raised to the positive 5 power. So that's going to become y to the fifth divided by x to the fifth. We raise each part to the fifth power. Okay, same type of thing over here. If I've got all of this raised to the negative 2 power, the first thing I'm going to do is to find my reciprocal and raise that to the second power. So when I do that, remember that 3 gets raised to the second power as well. So this would be 3 to the second power, and then m to the fourth to the second power, divided by 7 to the second power. So we would end up with 3 to the third power, which is 9. M to the fourth to the second power is m to the eighth, and then 7 to the second power is 49. Okay. Looking at one more of these, 2a to the squared divided by b to the third, all raised to the negative fifth power. So first thing I need to do is to find my reciprocal, and then this is going to be raised to the positive 5 power. So I take each individual piece. So first I'm going to have b squared raised to the fifth power, and then in my denominator I have 2 to the fifth power, and I also have a squared raised to the fifth power. So b to the second power raised to the fifth power would be b to the 10th. And then down here, 2 to the fifth power, 2 times 2 times 2 times 2 is 32. And a squared raised to the fifth power would be a to the 10th power. Okay, the rest of these we are going to look at tomorrow in class so that we can kind of bounce around some different ideas with these, because I know with all of these negative exponents and lots going on, it can be a little confusing. So we will take the time to look at some of those in class tomorrow, and I hope you have a great day.